spiacente. Perdóname.
Hey, come play with us!
No, I don't want to hang out with you guys. Giving birth to you hurt Mom. That's right, the birthing process harmed her. I don't want to play with you guys because I'm a big kid. I'm a big boy. I'm a big star. I don't want to hang out with you guys because you're littles. You guys stink. You guys are no fun. You guys are little and you guys are dumb.
We aren't little.
Yeah, you are little and you are dumb. I bet you don't even know what a force is.
Yeah, we do.
That's what I thought. I've got a pan and some kitchen supplies, and I'm gonna go have some big kid adult fun in my friend's basement. I'll check you guys later. Not.
I'm gonna wake up, yes and no. I'm gonna kiss some part of, I'm gonna keep this secret. I'm gonna close my body now.
It's a book about physics. It explains grown-up things like forces. It says here that force is any push or pull.
Wow! Awesome!
Well, there are a lot of things to be taken into consideration. Like, if you were to push on me with like 18 newtons of force, and I push back on you with 18 newtons of force, then we'd have a net force of 0.
What does that mean?
Well, it means that we won't be accelerating because all the forces acting on us are balanced out to 0, meaning there's no force that could move us, meaning we don't accelerate.
Well, can we try it, like, as pirates? So when our swords clash with the same amount of force, they don't move and no one wins. But when I apply more force to your sword, I win. Let's play ball!
See, the thing I don't get is why it stops. Like, when we were playing pirates, the sword only stopped because you were putting force on it. But why does it just stop on its own like that?
Maybe we can look in our physics book. I think this is a real case of
Friction!
Friction slows things down. And like in this scenario, when we try to roll the ball across the carpet, it didn't get to me. Friction depends on two things: the type of surface and how hard the two surfaces, the ball and the carpet, are pressed up together. I think we should try to roll our ball on a different surface. Maybe the tiled floor.
See, the ball doesn't stop because the tile has less friction than the carpet. The carpet grips the ball and makes it stop.
So now we can roll the ball like we always wanted to, since the tile is less frictionless than the carpet was. Yay! Let's go eat. Hey Andrew, I'm gonna throw these potatoes at you, okay?
Okay.
I have this 5 kg potato and this 1 kg potato. Now Andrew, tell me which one hurts more, 5 kg or 1?
Okay, well, it's just like throw them at 2 meters per second. Oh! Oh!
Andrew, which one hurt more?
Well, the 5 kilogram potato hurt more, but I don't know why, because if you throw them at the same rate, they shouldn't hurt more.
Well, I have our trusty physics book with me, so I can tell you, Andrew. Well, first off, momentum is a measure of how difficult it is to stop something. And with our equation, P equals mv, which means momentum equals mass times velocity, we can calculate the momentum for both the 5 kg potato and the 1 kg potato. Watch this. So, 5 kg times 2 meters per second equals 10 kg meters per second. That's a lot of momentum. Then, with the 1 kg times 2 meters per second, that equals 2 kg meters per second of momentum. Obviously,
This one would hurt more.
Yeah,
Because it had more momentum.
it had 10 kg meters per second of momentum. So, did you get a bruise from that potato
think.
anywhere? I'm really sorry. Come here! Potato! Psst! Psst! Come here! Come here! What?
Why are you tied up? And why are you talking to a potato?
This potato won't move. I don't know why. Do you know?
Well, Aneesa, haven't you learned anything today? See, it's not going to move unless a force is applied to it. That's Newton's first law of motion. It states that an object at rest, like this, will stay at rest, and an object in motion will stay in motion unless acted upon by an outside force.
Oh, that makes sense.
Yep.
But who came up with all these Newton's laws of motion?
Sir Isaac Newton.
Wow, he must have been a very smart guy.
Where there's a whip, there's a way.
So Andrew, I know a lot about forces, but what do you know about what Sir Isaac Newton knew about forces?
Well, Sir Isaac Newton's second law of motion states that force is equal to mass times acceleration.
So bigger is better.
So Andrew, since there's a first law and a second law, there has to be a third law of motion.
There is actually. See, you're actually demonstrating it now.
I am?
Yeah.
How?
See, you're leaning against the wall, right?
Mm-hmm.
And the wall's holding up. Because when you apply a force to something, it applies an equal and opposite force on you. And that's why you're able to stand there.
Wow.
So, chickies, what did you guys learn today?
Well, we learned what a force was. It's any push or pull.
We did some force vectors.
We learned about friction.
We did some momentum.
We learned about Newton's first law of motion.
Newton's second law.
And finally, Newton's third law of motion. It was a really fun day.
Learned a lot about physics.
How?
Doobie dum, doobie dum, doobie dum, doobie dum dum da doobie da ba doobie dum da doobie